Good morning. Today, let us study about electronegativity. What is electronegativity? We will also compare with the electron affinity. What are the differences between electronegativity and electron affinity? Okay. So, let us see electronegativity. Electronegativity, it is the property of an atom in a molecule. It is the property of an atom in a bonded molecule. It is a molecular property, or we can say this electronegativity is a molecular property. Electron, it is an atomic property. It is an atomic property. Okay. Now, let us define what is electronegativity. What is electronegativity? The tendency of an atom to attract the electron pair towards the bonded electron pair towards itself in a bonded molecule. Okay. Or it is defined as the ability of an atom. Ability of an atom. Fluorine is more electronegative, therefore it will pull the electron pair or it will attract the electron pairs towards itself. The ability of an atom to pull the electron pair, shared electron pair or bonded electron pair of electrons towards itself in a bonded molecule. What is electron affinity? What is electron affinity? We have already seen in previous video. It is the amount of energy when an electron is added to the valence outermost cell of an isolated atom in the gaseous state in its lowest energy state or ground state. So it is the amount of energy released when an electron is added to valence cell, outermost cell of an isolated atom in gaseous lowest energy state. Okay. Now, the electron affinity value is determined experimentally. It can be because it is the amount of energy released. It is exothermic reaction using bomb calorimeter. We can determine the amount of energy released experimentally. But remember, electronegativity is calculated from the experimental values by using the three scales we will discuss shortly. Okay. Now, next point is, you see, in periodic table, alkali metals, alkaline earth metals are electropositive because they have low ionization potential values. They are electropositive, and in the periodic table, the right hand side, halogens and oxygen family are more electronegative, and also they have high electron affinity values. Similarly, in periodic table, from left to right, or moving from left to right, or moving along in the period, the effective nuclear charge increases. Therefore, electronegativity increases. Electronegativity value increases in the period from left to right. Okay. Electronegativity value, electron affinity value increases in general. Similarly, on moving down in group in periodic table, the electron negativity value as well as electron affinity value decreases. Okay. So they have similarities. And also, what is another difference? For example, fluorine. Fluorine is the most. It is often asked, which is the most electronegative atom? Fluorine is the most electronegativity atom in the periodic table. It has the highest electronegativity value given. Okay, fluorine is more electronegative because it will pull the electron pair towards itself in a bonded molecule. Whereas in the case of electron affinity, chlorine is the most electron affinity value. Chlorine has the highest electron affinity value. Chlorine has the highest. Why? What is the reason now? Okay, it is often asked in various competitive examination because when an electron, see, it is very simple. Look at the definition. When an electron is added to fluorine atom, okay, and Z equal to 9, 1s2, 2s2, 2p6, because of small size and compact size, there is overcrowding. Because you have a lot of electrons. The shell is, the atom is very small in size. Because of the small size and overcrowding, there is an inter-electronic repulsion between the electrons. Between the electrons, there is an inter-electronic repulsion. Remember, there is an inter-electronic repulsion. This causes less tendency to accept an electron. Therefore, because of the inter-electron repulsion, fluorine has less tendency to accept electron. Therefore, it has less electron affinity value. Whereas in the case of chlorine atom, it is relatively big. It is small. It is relatively big, and also because of the availability of additional substrate, because of the availability 3s2 3p6, there is availability of additional substrate. There is less overcrowding. There is no inter-electronic repulsion, because the added electron can be delocalized to 3d vacant orbital, 3d empty orbital, because of the availability of vacant d orbital. The added electron can be delocalized. As a result, there is no inter-electronic repulsion. Therefore, chlorine has the highest tendency to accept electron than fluorine. Okay. Now, you may ask why fluorine, bromine and iodine has less value? Because when in the case of iodine, it is very big atom. It is very large in size. The added electron experiences less nuclear pull. The nuclear pull, the distance between the nucleus and outermost electron is very, very large. Therefore, the attractive force between the nucleus and the outermost added electron is very, very less when you increase the size. Therefore, the electron affinity value decreases with the increasing size. We have already seen in previous video. Now, how the electronegativity values can be calculated? There are three scales: Pauling scale, MULLIKEN'S scale, and ALRED, ROWCHOW'S scale, electronegativity scale. The first two scales are very important or commonly used. Let us first see Pauling scale. In Pauling scale is based on resonance energy. From the resonance energy, the electronegativity values are calculated. From the resonance energy, the electronegativity values are calculated. For example, H2 plus Cl2 gives HCl, or A2 plus B2 gives AB. And A is the bond energy of A2 molecule, EBB is the bond energy of BB molecule, B2 molecule, EAB is the bond energy of AB molecule, where Xa is the electron affinity of atom A, Xb is the electronegativity value of atom B. How the resonance energy is calculated? Resonance energy is calculated from the respective bond energies as follows: EAB minus square root of EAA into EBB. Okay, now the square root of del equal to Xa minus Xb, the difference in electronegativity values. Pauling arbitrarily considered or assumed the electronegativity value of fluorine equal to 4, and also electronegativity value of hydrogen is 2.1. Using this value, the electronegativity values of other elements are calculated using this value. For example, the density of water is 1, fixed. Similarly, here the electronegativity value of fluorine is assumed to be 4, assumed to be 4 by Pauling. Okay, now in kilocalorie, the bond energies are usually given in kilocalories per mole. This formula in kilocalories. In order to convert to electron volt, this is the formula. The factor 0.208 is multiplied by square root of del to convert kilocalories per mole to electron volt. Okay, this is the formula used to calculate. If it is given in kilocalories, first you calculate this and then you multiply it by this factor. And for hydrogen, it is known, then you can calculate the electronegativity of the other element. Next, what is the limitation? For example, it is used for molecules, elements in the molecular state. It is used for molecular elements, elements in the molecular state. It is not used for elements in the solid state. For example, sodium metal, lithium metal, iron. This method cannot be used. This is the drawback. What is the limitation of Paulink's method? This method is not applicable for elements in the solid state. Therefore, Mulliken proposed Mulliken's scale to obtain the electronegativity values of such elements. It is defined as the electronegativity is calculated from the average value of ionization potential and electron affinity values of the element. The electronegativity of an element is equal to IP plus electron affinity divided by 2. Okay. Now, this electronegativity value calculated using Mulliken's scale is 2.8 times greater than Paulink's scale. This value calculated is greater by 2.8 times. Therefore, to make it comparable, for example, molecular elements are calculated by this method. To make it comparable, it is divided by, see, electronegativity value IP plus EA divided by 2.8. Therefore, IP plus EA by 5.6 on multiplication. IP and EA are expressed in electron volt. See, if IP and electron affinity values of particular element are expressed in electron volt. Suppose if ionization potential and electron affinity values of an element is given in kilojoule per mole, not kilocalories, kilojoule per mole, then this formula is used, IP plus IE divided by 540. Okay. If the ionization potential and electron affinity values are given in terms of kilojoule per mole, okay, and 1 electron volt equal to 96.5 kilojoule per mole, and the advantage of this method is that different oxidation states, the electronegativity values of different oxidation states can be calculated. For example, oxygen, O2 minus, the electronegativity values of different oxidation states can be calculated. The third method, ALRED, ROWCHOW'S electronegativity scale method, is based on the electrostatic force of attraction between the nucleus and the outermost valence electron. According to classical physics, the electrostatic force of attraction between the two charged particles, is given by ZE. Effective E is the charge on the nucleus, and E is the charge on the electron. Therefore, ZE E square divided by R square, where ZEF is the effective nuclear charge. What is the effective nuclear charge? You will see the effective nuclear charge is equal to Z minus sigma, where sigma is the screening constant or shielding constant, where Z is the actual nuclear charge. For example, Z equal to 9. Number of protons. Z corresponds to number of protons. Okay. Therefore, the shielding constant or screening constant by using Slater's formula we have already studied. Okay. Therefore, to convert to common unit, 0.359 Z effective divided by R square plus 0.744. So, the electronegativity values can be calculated from the resonance energy, that is bond energies, or ionization potential, electron affinity values, or from the electrostatic force of attraction. Okay, so there are several questions based on this. Please understand the fundamentals so that you can apply to any problems or any questions. Thank you for watching. We will see applications of electronegativity in the next class.